Welcome to part 4 of ionic bonds. In this video we're going to be talking about naming ionic compounds. So if I gave you a compound like lithium oxide, I'm going to show you a way in which you are able to give me the chemical formula of this compound. It's a way in which we can show you how to name it without having to remember these compounds. There are so many compounds out there in the world that it would be impossible to remember them all. So you need a technique to show you how to do this. So what we can say is, and please go and watch the previous videos if you don't understand why sodium becomes a +1 charge. Okay, so we spoke about sodium chloride, it became a +1, the sodium, the chlorine became a -1, and these formed ions, and that's why they formed an ionic bond. We can actually say that all group 1 metals, I'm going to do this in red, all group 1 metals form a +1 charge. All group 2 metals form a +2 charge. All the elements in this group form a +3 charge. All the elements in this group form a neutral charge or 0 charge. Then we have elements in this group form a -3 charge, -2, and -1. Now you can go and fill this in on your periodic table at the beginning of your exam. You can just say +1, +2, +3, neutral, -3, -2, -1. So all those elements have those charges and form those ions. I've just simplified the periodic table here to make it a little easier for me when I start to do some examples. The transition metals I'm going to talk about a little bit later. They are slightly different, and some transition metals will have 2 charges, and I'm going to speak about that in a second. So let's do some examples. So let's take our example that we used earlier, and let's say the exam says I want you to give me the chemical formula for lithium oxide. So what do? Okay, what we do is we find the 2 elements in my compound. We've got lithium over here. Lithium has a +1 charge, so I've got lithium and it's got a +1 charge. I'm just going to put plus and assume that by leaving out a number that I am talking about a 1 here. Okay, oxide, remember when a element has a charge, remember we talked about chlorine when it is in a, sorry, I almost wrote chloride there. When chlorine is in a neutral state, it's called chlorine, but when it is a ion, when it's got a -1, it's called chloride. Okay, notice the difference at the end. Same thing here with oxide. That is just another name for oxygen when it has a charge, when it becomes an ion. So oxygen is sitting over here in this group and it's got a -2 charge. So I can say 2-. Okay, some people say -2. I like to put it as 2-. Now when we name ionic compounds, what we need is for both sides to have the same charge. Okay, what do I mean by that? Well, if you count the amount of atoms here, we've got 1 lithium atom and we've got 1 oxygen atom. What's the total charge on the left hand side? Well, there's just a +1, right? And on this side we've got -2 from the oxygen. So how would I balance these sides? I would need to get another +1 on this side. So what I can do is I can add an atom of lithium, I can add an ion of lithium, and this will give me +2 on the left hand side. Okay, so this will be now +2 because of these 2 atoms of lithium, and on the right hand side we've got 1 atom of oxygen with a 2-. So what does this mean in terms of the chemical formula? Well, if we've got 2 atoms of lithium, we can say this, Li2, and we've got how many atoms of oxygen? We've got 1 atom of oxygen. So here is my chemical formula for lithium oxide, and that is the technique you would use. Let's do another one. I'm gonna pause. You're gonna pause the video at this point and see if you can use the technique I've just shown you. So let's do another one like potassium nitride. Now remember, nitride is just the form of nitrogen when it has a charge. Pause the video and see if you can give me the chemical formula for this compound. See? Okay, so we got potassium nitride here. Let's have a look at my simplified version of my periodic table. Potassium, that's number K, not number K, letter K. It's got a +1 charge, so I can say K plus. We've got nitride, which is sitting in this -3 category, so it's got N3 minus. Now how I'm going to balance this? Well, I'm going to add two more atoms of potassium to give me a total of +3 on this side and -3 on this side. So my chemical formula for potassium nitride will be K3N. Making sense? Hope so. Let's try one more example. What about sodium chloride? Okay, sodium chloride, nice easy one. Now you guys all know that sodium chloride is NaCl, but let's use the same technique. So we've got sodium, which is in this group. It's got a +1 charge, Na plus. Chlorine, it's got a -1 charge over here. So then this would be Cl minus, and these actually balance out quite nicely. So this is why sodium chloride is only NaCl. Beautiful. Okay, what about talking about something else? Okay, let's go and move on and see if it gets any more difficult. Okay, let's just go a little bit further down. Don't forget to use your periodic table all the time. Okay, polyatomic ions. Now, polyatomic ions are basically groups of atoms that have a charge. So when N and 4 H's are together, they have a +1 charge, and this is called ammonium. You're just going to go and learn these polyatomic ions and the charges they have. Unfortunately, it's just something you have to go and learn, write down at the beginning of your exam, and so that you know all the charges. Carbonate, CO3 2 minus, hydroxide, OH minus, nitrate, NO3 minus, phosphate, PO4 3 minus, and sulfate, SO4 3 minus. You're just going to have to go and learn them. Okay, so let's do an example of a chemical formula. They say, I want you to give me the chemical formula of ammonium nitride. Okay, ammonium nitride. Well, what have we got here? We've got ammonium. So what you would write is NH4 plus. Okay, this whole, not just the hydrogen, but the whole polyatomic ion has a 1+ charge. Now remember, nitride is not nitrate. Okay, nitride is just simply, if we go back up, it's just simply nitrogen with a charge. So it's actually N3 minus. So we've got N3 minus. So how do we balance out these charges? Well, we're going to need to add 2 more ammonium molecules, okay, which is going to give me a total of a +3 charge, because each of these have a 1+ charge, and we've got a 3- charge here. So how would I write this now that I've got 3 polyatomic ions? This is when you will use brackets. So we go NH4, I've got 3 of those plus my nitrogen. Okay, that's a simple example. You don't write any of the pluses or the minuses. Once these two things are together, these fall away. Okay, beautiful, beautiful, beautiful. Let's try another example. So just get rid of that. Let's try another example. What about sodium carbonate? Sodium carbonate. Beautiful. Okay, sodium carbonate. Remember, sodium is in group 1, so it's got a +1 charge. I can show you quickly. Remember, sodium, there it is, +1 charge. Okay, and carbonate is a polyatomic ion. You just got to be aware of that word carbonate. As soon as you see carbonate, you write CO3 2 minus. So what's our total charges on each side? We've got 2 minus on this one side, we've got 1 plus on this side. So we're going to need to add another sodium, so that we've got +2 and -2. So it's going to be Na2CO3. And you can just leave it like that. You don't have to put any of the charges. Okay, let's try another one. What about magnesium? Whoopsie. What about magnesium? Magnesium phosphate. So let's say magnesium phosphate. Okay, pause the video and try this one by yourself. Cool. Magnesium. Where's magnesium? It's not a polyatomic ion, so we're going to consult our periodic table. Magnesium is in group 2, so it's going to have a +2 charge. So this is Mg2 plus, and phosphate is PO4 3 minus. Now this is a slightly difficult one because we've got a 2 on the one side and a 3 on the other side. So what can we do here? Well, there's a clever, whenever you get a 2 and a 3, there's a clever way in which you can do it. You add one more of the 3's. Okay, this gives me a total of -6 because of -3 and -3. And how do we get 2 into 6? Well, you just add 2 more. Okay, so you got Mg2 plus, Mg2 plus, and this gives me +6. So now, Mg3 atoms, 1, 2, 3, right? And we've got 2 of these phosphates. So we need to put brackets for the phosphate, and then A number 2. Okay, awesome. Let's move on. These are your polyatomic ions. Go and learn them. They'll be part of your notes. What about these transition metals? So remember in the beginning of this video, I said I would be talking about what are these transition metals like gold and silver and copper and iron? What kind of charge do they have? Well, all metals form positive ions. We can see this from things like sodium and magnesium, right? Sometimes, well, not sometimes, but most of the time, you will be given a Roman numeral for one of these transition metals, like lead, okay? And if the Roman numeral is 2, you can simply say lead is Pb2+. Iron, for example, exists with 2 different charges, but they might give you the 2, then you just write Fe2+. If they give you the 3, you write Fe3+. Copper also is one of these transition metals with a Roman numeral, copper 2+. So for example, what if they say, can you name this compound, iron chloride? Okay, how would I work out how to name this compound? Because we've got 2 forms of iron. Like, is this iron 2 chloride, or is this iron 3 chloride? Okay, which one is it? We know that iron exists as Fe2+. Is it Fe2+ or is it Fe3+? Right? We don't know this, but we can work it out because we know what chloride is from the periodic table. And from those that can remember, I'm not going to go back and check, but from those that can remember, we know chloride is a -1 charge, right? So chloride is -1. We've got 3 of those atoms, so we can add 3 here. And what would this be on this side? It would be a -3. So what ion am I going to be using? We can work out we need a +3 on the other side, so it's definitely going to be +3. So this compound would be called iron 3 chloride. Don't forget to write chloride at the end. Beautiful, beautiful, beautiful. All right, everybody, these are the transition metals, and this is how you would name them from the Roman numerals. Unfortunately, there are a few more that you will just have to go and learn. Whenever you see zinc, it's always zinc 2+. Whenever you see silver, it's Ag+. Whenever you see hydrogen, it's H+. Okay, let's do an example. Okay, we've already done this one over here. Let's do this one. Iron sulfate. Iron 3 sulfate. Remember, iron 3, you just simply write iron 3+. I'm going to go consult my polyatomic ion page for sulfate. Let's go back up. Sulfate, SO4 3-. Okay, let's go back down. SO43 minus, SO43 minus. Ha! Look at that. We've got +3 and -3. So this is simply going to work out to be FeSO4. This is how you would give the chemical formula for iron sulfate. In fact, yes, that's perfect. It's perfect for iron sulfate. Guys, have a look at this video a couple of times. It's going to take you a little bit of time to get used to these naming ionic compounds, but I hope it's been helpful.